Lecture number 9, Basic Switch Concepts and Configuration. In lecture number 8, we discussed about the basic things about the switches. So what is a switch? What are the differences between a switch and a router? What are the types of switches? So how the switch is working? So the basic things we discussed in lecture number 8. So today we are going for configuration, basic switch concepts, and we are going to do some basic configuration we are going to see. Okay, so practically we are not going to do, we are going to do theoretically only in this lecture. In the next lecture, lecture number 10 and 11, okay, we are going to do the configuration inside the switches. Now, in this lecture, we are having 6 different parts. So the first part is switch introduction. Second part, it is a basic switch configuration. The third part is layer 2 and layer 3 issues. Then we are going to discuss about SSH configuration, security concerns in local area networks, and finally we are going to discuss about switch port security. So these are all the major topics that we are going to discuss. Okay, that is part 1, part 2, part 3, 4, 5 and 6. Now let me go for the first one, switch introduction. So this is the first part in this particular lecture. Now the first thing what we are going to discuss here means this is the switch boot sequence. So what is a switch boot sequence? What do you mean by a boot sequence? Means not only in switch, so in router also the same process is going on. Okay, so both in the router and the switch, the same process, the same steps will be going on. So what is that boot sequence means? You take, I'm having a laptop. So I'm going to switch on my laptop. Okay, I'm just going to switch on my laptop. So once if I switch on my laptop, so in my laptop there are so many things going on. And finally, the Windows operating system, okay, the Windows operating system is loaded. So this process we are going to say it is a booting process. Even in your mobile phone, you can take your mobile phone, you can switch on your mobile phone. Okay, so once if you switch on your mobile phone, there is something happening inside, and finally, okay, your operating system. So either Android operating system or iOS operating system. So the operating system will be loaded. Okay, so this particular process we are going to say as the boot sequence process. Now, if I switch on my switch or a router, okay, anything. If I just switch on means I just make on. That means I'm going to give allow the electricity to pass. If I make it on, what is the first step going on means the first step is called post, power on self test. So what is this power on self test? Okay, what do you mean by power on self test means the device, that means the switch or the router or a system, okay, a computer, it will check its own parts. Okay, for example, if you switch on your computer, the first step is a post, power on self test. So in the power on self test, your PC will check, okay, the keyboard, it will check the monitor, okay, it will check the mouse, okay, it will check the RAM, okay, the hard disk. So everything, all the internal components, okay, the device will check, okay, everything is connected properly or not. Suppose if anything is not connected properly means it is going to give you a error message. Okay, that is called the post, power on self test. So in the switches and the routers also, the power on self test is going on. So it will check everything, all the memory, okay, everything is connected properly or not. So it will be checked by the post, power on self test. Then once the power on self test is over, the next step is, okay, it will search for a bootloader. That means the bootloader software is going to run. So what exactly this bootloader software is going to do means this is going to find where is the operating system. Okay, where is the operating system? Then it is going to load the operating system. The operating system will be loaded. So now once the power on self test is completed, the next step is running the bootloader. So the bootloader, it is going to search, it is going to find where is the operating system, IOS. So IOS means Inter-Network Operating System, Internetworking Operating System. Okay, this is the operating system available in the switch and available in the router. So now the bootloader software, it is going to search where is the IOS file, where the IOS file is stored. So sometimes the IOS file will be available in the registers, or it will be available in a flash, or it will be available in the TFTP server, okay, FTP server, or it will be available somewhere in the ROM. So in any place, okay, the IOS can be available. Either it will be available in the device itself, that means in the register itself, or it will be available in the flash memory, it will be available in the FTP server, or you can find it in the ROM, read-only memory. So somewhere, okay, the IOS will be available. So the bootloader software is going to find where it is available. So if it is available in the register, it is going to load the IOS. If, okay, the IOS is available in the flash memory, okay, it will be loaded. In the FTP server, it will be loaded. So your bootloader software is going to search, is going to find where exactly the IOS software is available. So somewhere the IOS software is available, so the IOS software will be loaded. Now we are going to get, okay, that means the operating system is ready. Then the next step is, suppose if you have done already some configuration you have done, you have completed some configuration already means, so it is going to search for the configuration file. Okay, where is the configuration? Already you have configured a static route, some, okay, RIP protocol, OSPF protocol, okay, you have changed the name of the router. So some configuration you have done already means, so this configuration, where the configuration means will be available means, the configuration file will be available in the NVRAM. So we know RAM, okay, random access memory. So what is NVRAM means? Non-volatile random access memory. So in the RAM, from the RAM, okay, it will load the configuration file if it is available. So if it is available, yes means the configuration file will be loaded. Okay, startup configuration will be loaded. If the configuration file is not available means, okay, it will go to the setup mode. It will ask you to create the configuration. Okay, so if no configuration file, you will be asked, you will be requested to do the configuration. Okay, so this is how the boot sequence is working. This is not only in switch. Okay, it is not only for the switch. So even if you take a router, these are the steps. Okay, so first power on self test. First you are going to switch on the device. Okay, once the device is switched on, okay, you are going for the power on self test, POST. Automatically this will happen. You don't need to do anything. You just take a switch and make it on. All the steps, okay, it is going to run automatically. So power on self test, that is the first step. Then the boot loader, or we can say bootstrap loader. So this software is going to search where is the IOS. Okay, so it will find the IOS either in the register or in the flash or in the TFTP server or in the ROM, so somewhere. So it will find it somewhere. Okay, now your operating system, that means the IOS will be loaded. Then searching for the previous configuration file. Is there any configuration file available? So usually the configuration file will be available in the NVRAM. So if the configuration file is available means, okay, it will be loaded and your switch or the router is ready. Okay, you can continue with that. Suppose if the configuration file is not available means, it will ask you to do the configuration. It will go to the setup mode and it will ask you to do the configuration. So this is called the boot sequence. So how the boot sequence process is going on in the switch and the router. Now, so these are the three major steps. The three major steps. What are the three major steps means? The first step is going to be the automatically boot by using the information in the boot environment variable. Suppose if it is not available, if the variable is not set, that means if the IOS is not available in the register, it is going to search. It is going to search somewhere. Okay, it will search in the flash, it will search in the ROM, it will search in the FTP server. Okay, somewhere it will search and it will execute. Then finally, we are going for the configuration file. So the configuration file, generally it will be stored in the NVRAM, non-volatile random access memory. So from the NVRAM, okay, we are going to take, okay, the configuration file, and the configuration file will be loaded. So this is how, okay, the boot process is going on. So this is the first concept we are discussing here. Then the second thing is recovering from a system crash. Suppose if the IOS cannot be loaded, okay, we discussed how the IOS will be loaded in the previous step. Suppose if the IOS is not able to load, okay, if we cannot load the IOS, that means there will be some problem in your operating system. Okay, you just take, I'm having a laptop. I just switch on my laptop today, but I'm not getting the Windows. Okay, the Windows operating system is not loading. It's showing some error. So I'm going to say the system is crashed. My operating system is not properly working. So suppose if there is any issues available in the IOS, if the IOS cannot be loaded, okay, what we can do? So what we can do means you can use these 3 steps. So what is that means? You can connect a PC, a computer, using a console cable. So the console cable, it will be in blue color. In lecture number 2, sorry, not 2, lecture number 3, we discussed about this. So you can take a console cable, you can connect with the switch, then you can unplug the switch power cord, then connecting the power cord to the switch and press the whole OK mode button. So what does it mean? It's very simple. So suppose if your IOS is not loading, what you have to do? You have to either change your IOS, okay, or you have to upload, okay, you have to upload a new IOS, you have to upload to your device. So how you can do this means, in a switch there is a button called mode button, okay, you can see it in the next slide. So you have to press this, okay, mode button for some time. So if you press, okay, automatically it will connect with the PC, then you can exchange, you can transfer, you can load the software and you can replace the operating system. Now if you see in the next slide, this is called the mode button. Okay, this is a switch. So in the switch we are having a mode button. So this mode button you have to press for a while and automatically it will be connected, okay, for reconnecting. So what we are understanding from this slide means there are chances available for IOS to be crashed. Okay, if you are not properly handling your devices, either the switch or the router, if you are not handling it properly, okay, so there are chances available for the IOS crash also. Then the next one, switch LED indicators. So what is that switch LED indicators means? There are lot of lights, LED lights available. These are all LED indicators which are available in a switch. Okay, there are so many lights available. We no need to memorize all these things. So once if you work with the switch, if you are becoming an administrator and if you are working with a switch, you will understand very easily this is. But exam point of view, you no need to memorize, okay, all these things. Now, what does that means? There are plenty of switches available. You can see here. So the first one, it is a system LED. Then the next one is RPS LED. Then the next one, it is port status LED, port duplex LED, port speed LED, then power on Ethernet LEDs. So these are all different types of LED lights available. Okay, so now if you see the system LED, what is system LED means? Suppose your switch is now on, it is connected with the electricity, and okay, the switch is on means, so you are going to see this system LED, it will be in green color. Then redundant power system LED, port status LED, okay, there are so many different varieties available. Okay, I'll just tell one or two, okay, that will be enough. You can see, suppose if duplex, today we are going to discuss about this duplex concept. Okay, then status LED, sometimes these lights will blink. Okay, there will be 3 different colors. So red color, green and amber. So in red means there is something serious error. So if it is green means it is working properly. So amber means, okay, in between, it may be learning something or it may be reading something. So these are all the different colors will come here. Okay, so this is not that much important, but you have to understand there are so many different types of LEDs available. Okay, like system, RPS, master, stat, duplex, speed, stack, PoE, power on Ethernet. So these are all the different types of LEDs available in a Cisco switch. Not only in switch, even in the routers, there are some LEDs available there. So this is the end of part 1. So in part 1, what we discuss means it is just a small introduction to the switch. Okay, a switch introduction. There are 3 things we discussed here. Switch boot sequence. Next one is a crash. Then the third one is a LED. That means switch LED indicators. Now, I'm moving on to the second part of this lecture. So what is the second part of this lecture is the basic switch configuration. So we are going to do some configuration in the switches. So up to lecture number 8, we were doing configuration in a router. Okay, you can change the name of your router. You can create a static route. You can fix an IP address. You can create a default route. You can configure the RIP protocol. Okay, OSPF protocol, single area, multi-area. So all this configuration we have done inside your router. Same thing, inside your switch also you can do some configuration. Okay, almost the commands will be same here also. Okay, now basic switch configuration. This is part number 2. Now, the next one, first one, I'm going to prepare for a basic switch management. So what does that means? You can manage your switch remotely. So what is remotely means? So your switch is available somewhere. Okay, my switch, it is available somewhere. Okay, this is available in the college. Okay, I'm sitting here. So I'm sitting in my home. Now I want to enter into the switch and I want to do some configuration means I can do it by using a remote method. So what is the remote method means? By using the telnet. Okay, you can use the telnet, and using the telnet concept, you can enter into the switch and you can do any configuration you can do. So if you want to make a remote login, this is called the remote login. So if you want to make a remote login, you need an IP address. So for a switch, you can configure a IP address. You can configure a subnet mask. Okay, even you can configure a gateway, a default gateway. So everything we can configure for a switch. Okay, you can fix an IP address, subnet mask, default gateway. So everything you can configure for a switch. So that means you can have an IP address. Okay, you can see the IP information. So the IP information is IP address you can fix, subnet mask you can fix, and gateway you can fix a gateway to be assigned for a virtual interface. So for an interface, what is virtual interface? You will understand later. So for an interface, that means for a switch, you can fix an IP address, you can fix a subnet mask, gateway, everything you can fix. And you can make a remote management. Okay, you can enter into a switch by using a remote management or remote entry like telnet. So telnet is a very popular. We have done in lecture number 3 or 4, I think. Okay, we have done how to make a remote login. So this is how you can prepare your switch. Okay, you can prepare your switch like this. Then you can see some commands. The same commands we have done for the routers also. Okay, you can see. I just go to the switch. In router, you will see router here. But in the switch, you are going to get switch, SWITH. The first command, I'm going to use the command config terminal. So we know config terminal command. What is a config terminal command? We already used this command in the router. So this command will take you to the global configuration mode. So I'm giving config terminal. So it is taking me to the config. So I am in the global configuration mode now. Then I'm going for an interface. The name of the interface, you can say interface. You can use fast Ethernet 0x0, fast Ethernet 1x0, fast Ethernet 2x0. You can give any name, okay, the name of the interface, and you can enter. It will take to the specific configuration mode. So this is called the specific configuration mode. But I'm using here VLAN 99. So what is this VLAN 99? You will not understand in this lecture. The next 2 lectures, okay, lecture number 10 and 11, it is going to be VLAN. Okay, VLAN, that is going to be your next lab exam. You are going to take the next lab exam in the VLAN concepts. So VLAN is going to be a very important concept as far as the switch is concerned. So VLAN 99, I'm going for the interface VLAN 99. What is VLAN 99? Okay, you will not find the answer now. You will find the answer in the next class. That means in the next lecture. So VLAN 99, this is called a SVI, switch virtual interface. So I'm going for VLAN 99. For VLAN 99, I want to fix an IP address. So what is a command to fix IP address means IP address. You can use IP address and subnet mask. So IP address 172.17.99.11. I'm giving an IP address. So without any subnet mask, I'm just giving an IP address. So now the IP address is fixed for VLAN 99. Then the next command is no shutdown. So what is no shutdown means? I'm going to enable this VLAN 99. I want to enable. I want to make it on. I want to change the status to up. So I'm giving no shutdown. Then finally you can give end or exit. Anything you can give. Now you can see copy running config startup config. This command also we already discussed in the routers. So what does that means? So this will save all your configuration, whatever the configuration you have done, all the configurations will be saved to the startup configuration. So the commands, it is almost the same. Almost same. What are the commands we discussed in the routers? Almost the same commands we are going to use it here. So config terminal means this is changing. It will take you to the global configuration mode. Then interface VLAN 99. So VLAN 99 is the name of a interface. So this is a virtual interface. You may not understand this now. No issues. You can fix IP address. Then you can make this VLAN 99. You can make it enable. That means you are going to make it on. No shutdown. Then we are going for copy running config to startup config. So almost the same commands it will be available in the both in the switches and the routers. Now the next command you can see, I want to fix a default gateway for my switch. A default gateway. So if you go to a PC, you can take a PC, you can fix three things. One is IP address, second one is a subnet mask, and third one is the gateway. So same like that, already I fixed the IP address. Now I want to fix a gateway for my switch. A gateway IP address. That is the IP address of your router. Now you can see I go to the switch. S1 is the switch. I'm going for global configuration mode. Config terminal. So if I give config terminal, so it will take me to the global configuration mode. Now I want to fix the gateway. So what is the command means? IP default hyphen gateway. So default gateway, you can fix an IP address 172.17.99. That should be something here. It is missing because IP address should have 4 ports. So 172.17.19.99.10, that will be 10. So I'm fixing a gateway for my switch. Then I'm going to give end. Again, I want to save these changes. Whatever the changes I have done, I want to save it. So copy running config startup config. So this is the way how you can fix a gateway for your switch. So in the previous slide, we discussed about how to fix an IP address for a virtual interface. For VLAN 99, it is an interface. So for this interface, we fix the IP address, and here we fix the gateway for our switch. Now, the next one, this is the basic configuration. How you can fix the IP address and default gateway for a switch. The next concept is duplex communication. A switch can do a duplex communication. So what do you mean by duplex? First we'll go for off duplex. There is something called off duplex. So off duplex communication means you can send or receive the data one at a time. Either you can send the data or you can receive the data. You can do only one at a time. That is called off duplex. You can take the old telephones, like the policemen, they used to use something called a walkie-talkie. So walkie-talkie is a off duplex device. So first they will say hello, then over. So if you say over, then the next person will talk. That is walkie-talkie. So in walkie-talkie, it is a off duplex device. So you can send the data or you can receive the data, okay, at a time. You cannot do both at a time. But if it is a full duplex communication, okay, the mobile phones, even, okay, our communication, so we are all in full duplex communication. So what is full duplex communication means? You can send and receive the data at the same time, simultaneously. You can send and receive the data. Now, so the switch, okay, I'm connecting a switch. Okay, this is, I just connected the switch. So this link, this communication link, I can make this link as a off duplex link, or I can make this link as a full duplex link. Okay, we can do. These are all the configurations. Okay, I want to make this as a off duplex communication means we can make it. I want to make this as a full duplex communication means we can do the configuration. I want to change the speed of this link. The speed of the link I want to change. You can do it. Okay, let us see. In the next one, you can see here, I want to do the configuration. See, this is PC1, PC2, switch 1, switch 2. Okay, very simple question here. How many networks available? In this topology means this is only one network. Okay, this is a local area network. Okay, we don't have the router here. So if there is no router, so easily you can tell it is a single network. So routers are used to connect the two different networks. But here I don't have any router device. I have only switches and PC. So this is a local area network, only one network available here. Now, in this, you can see S1 to S2. So S1, okay, S2, they are connected by using a cable, and name of the interface. Here the name of the interface is Fast Ethernet 0x1, and here also the name of the interface is Fast Ethernet 0x1. Now, this link, I want to make this as a full duplex link. Okay, I want to make this as a full duplex link. So how to do it? Now you can see, I'm going for S1 first. Okay, I'm going for the switch 1. Just double click the switch 1 in packet tracer. So you are going for the switch, enable, then config terminal. We will do these commands in the next class. Okay, config terminal. I'm going to type the command config terminal. So it will take me to the global configuration mode. Now I'm going to type the command interface Fast Ethernet 0x1. Interface Fast Ethernet 0x1. So I'm going to this interface. Then I want to make this as a full duplex. Now duplex full. So this is the command duplex. I make this as the full. So full duplex now. So this particular interface now I converted into full duplex. Then you can see the speed. Speed I'm giving 100. So that means how many megabits per second. So you can adjust the speed also 100, 200, 300. So you can increase the speed and you can decrease the speed. So speed I'm going to fix 100 megabits per second. So two things I have done. I'm just entering into the interface Fast Ethernet 0x1. So Fast Ethernet 0x1, I'm just making this as a full duplex, duplex full. Then speed, I'm going to convert this into 100. What is 100 means? 100 stands for megabits per second. Then the next one is, I'm just going to exit. Now I'm going to use the command copy, running config, startup config. So this command, it is going to save this particular configuration. I'm just saving this configuration. Then again, you have to go to the switch 2. In the second switch, you have to enter. You have to do the same thing. So go to the interface Fast Ethernet 0x1, make the duplex full, speed 100 and save it. Copy, running config, startup config. So if I do, automatically this link is now going to be a duplex link with a speed of 100 megabits per second. So you can do the changes, you can do some configuration in your switches, okay, inside the switch, okay, same like routers. Okay, it's almost same, like almost the commands we used in the routers, 50 to 60% of the commands you can use it in the switches also. Then the next one you can see here, auto MDIX feature. So this is a very interesting feature available in a switch. Okay, what does it means? if you take the devices, okay, for example, if you take the similar device means I'll write it here. So switch and a switch. Okay, if you want to connect a switch and a switch means this is called similar device. I'm connecting a switch and a switch. So I'm connecting this device. If you connect the similar device, you need a different type of cable. Okay, you need a different type of cable. Suppose if you connect a PC, I'm connecting a PC with a switch. Okay, with a switch, I'm connecting a PC with a switch means you need a different type of cable. So you might have studied about these cables in data communication, the previous course, but no issues. I will just give you, okay, some basic idea. Now, a PC and a switch means these are all different device. So a PC is a different device and switch is a different device. So what type of cable you have to connect means, if you are connecting different devices means you can use the straight through cable. Okay, straight through cables we can use. But if you connect the similar device, switch to switch or PC to PC, I'm taking a PC, I want to connect this PC with another PC. Okay, PC to PC if I want to connect. So these are all similar devices. Okay, so here you have to use crossover cable. So similar devices, if you are connecting, you need a crossover cable. Okay, see the same thing. Switch to switch, you need a crossover cable. So a crossover cable should be used. Here, the same thing. A switch to switch, switch 1 to switch 1. What type of cable I want to use? I have to use a crossover cable. I have to use. Now, suppose I don't have crossover cable. Okay, I don't have crossover cable. Okay, because crossover cable many people they will not have. So generally, if you go to the market, you will find only the straight through cables. Okay, straight through cables only, it will be available freely. So now I'm having only a straight through cable I'm having. So now I can connect a straight through cable here. No problem. You can connect. But what you can do means you can enable a feature. There is a feature available which is called auto MDIX feature. If you enable this problem will be solved. So you can use any cable. You can use a if you are using a crossover cable, by default it is correct. I don't have crossover cable. I have only straight through cable. No issues. Connect it. Okay, connect it. You can use the straight through cable and you can enable this auto MIDX feature. If I enable this, the problem will be solved. It will be considered. Okay, you see. There are certain cable types. Okay, straight through cable or crossover cable. So historically required when connecting the devices. So if you connect similar devices, you need crossover cable. If you connect different devices, okay, you need straight through cable. So if you enable this auto MDIX, so what is auto MDIX means? Okay, auto means automatic, medium. So medium means cable. So automatic medium dependent interface crossover. So the X stands for crossover, automatic medium dependent interface crossover. So if you enable this this particular feature automatically, so okay, you no need to use the crossover, you can use the straight through. The straight through will be considered as a crossover here. Okay, you can see auto MIDX is enabled. The interface automatically detects and okay appropriately configures the connection. So it will detect what type of cable you are using. So based on that, automatically it is going to react. So this feature you can enable. So using auto MIDX on an interface, the interface speed, okay, duplex must be set to auto. You can see the command. So I'm going to this switch. I go to fast Ethernet 0/1, interface fast Ethernet 0/1. I'm going to make duplex auto. We already studied what is duplex. Speed also, I'm going to make it auto. I'm not fixing 100, 200 like that. Okay, I fix it auto. Now I'm going to use MDIX. Okay, MDIX. So automatic media or medium dependent interface crossover. I make it auto. So if I make it auto, you can use a straight through cable here. Okay, so there is no problem. So you can use a straight through cable and automatically it will work. So these are all the basic configurations. You can see in the next slide. So here they are using a straight through cable. Okay, the auto MDIX feature is enabled here, and just they are going to display show controllers, Ethernet controller, fast Ethernet 0 by 0. Okay, just they want to see what is available in fast Ethernet 0 by 1. Okay, this is a show command. Now you can see auto MDX is on. So you can make auto MDX on. Okay, you don't need to memorize this command, but the concept is important. So you can make the auto MDX, you can make it on. So if you make it on, you can use a straight through cable instead of crossover cable. Okay, so these are all the basic configurations. Okay, the basic configurations we can do. Then you can see there are list of show commands. There are plenty of show commands available. So show commands almost it is same in the router and in the switch. Okay, it is going to be same. Okay, so what are the show commands? You can see the first show command. You can see show interface interface ID. Okay, show interface means you can use the command show interface fast Ethernet 0 by 0, fast Ethernet 0 by 1. So this will give the information about the interface. Okay, it will display the information about the interface. Then the second show command, show startup configuration. So startup configuration means, okay, the same command you can do it in the switch on the router. So it will display all the configurations that you have saved. Okay, all the configurations which are saved in your device you can display. Show running configuration. So these are all the configuration which is running, which is not saved. Okay, there is a difference between these two. This is completely saved and this is not saved. You have done some changes to your router, but it is not saved. That is called running configuration. Then show flash. So this is the information which is available in the flash memory. Show version. What is the iOS version? So all these commands we will do it in the next lab. That means before configuring VLAN, all the commands I will do. Okay, I am going to do it in the switches. Then we will start the VLAN, virtual LAN. That is the next concept. Then show history. So this command we already studied in the routers in lecture number 3. By default, okay, in the history there will be 10 commands. Okay, the 10 commands will be stored. You can increase the size of your history. You can decrease the size of the history. So history command we already discussed this, okay, in router in lecture number 3. Then show IP interface ID. So you can give, okay, any interface ID. Show IP fast Ethernet 0 by 0, fast Ethernet 1 by 0. Okay, like that. Then the next very important thing is show MAC address table. In the switch, sorry, in the router, we used a command. Okay, frequently we use the command show IP root. Okay, show IP root. So this is a command we used in the router very frequently. So what is the purpose of this command means? So this command is used to display the routing table. Show IP root. So your router is having a routing table. Okay, so it is having a routing table. So we display the routing table by using the command show IP root. But if you are going for the switches, in switches we are having MAC address table. Okay, MAC address table. So the MAC address table, how you can display the MAC address table means you can see the command show MAC address table. In the last lecture, that means in lecture number 8, we saw the differences between the switch and the routers. Okay, video is available. I shared the video yesterday. So in that, the first slide, if you see, what are the differences between a switch and a router? Router is maintaining the routing table. Switches are maintaining the MAC address table. We can say MAC address table, or we can say CAM table, CAM. Okay, just reverse, CAM, CAM table. okay, anything. So how to display the MAC address table means show MAC address table. Okay, so these are all the basic show commands which are available, which you can use it in the switches. Okay, so the second part of this lecture we are discussing about the basic switch configuration. Now let me go to the third part of this lecture. So the third part of this lecture is issues, problems, layer 2, layer 3 issues. Okay, what does that means? You can see I use the command. Okay, just now we saw this command show interface fast Ethernet 0 by 1. Okay, so I just display the information about fast Ethernet 0 by 1. Okay, now you can see. So fast Ethernet 0 by 1 is up. It is up. Up means we have fixed some IP address. It is working. Then you can see there are so many other things available. So what does that means? You see 0 runs, 0 JAINs. Okay, then 3 input errors, 3 CRC errors. So these are all called errors. Okay, 0 runs, 0 JAINs. Okay, 3 input errors. Okay, 3 CRC errors. So what is this mean? This is different types of errors available in a packet. Okay, now you can see runs, JAINs, input error, CRC, output errors, collisions and late collisions. This is a very, very important question. So what is a runt? What is a JAIN? Okay, input error means what? Output error means what? Collision means, okay, this will happen for every interface. In every interface, fast Ethernet 0 by 0, if you go to fast Ethernet 0 by 0, you can find some runs, some JAINs, okay, some input errors, CRCs, okay, output error, collision, late collision, okay, everything is given here, okay, you can see 235 late collision, okay, 235 late collision, then 3 input errors, 3 CRC errors. So what exactly this? These are all some types of errors. So what is that means? Okay, we'll go for the runs. So okay, first we'll go for the JAIN. So what is a JAIN? What do you mean by JAIN means? It's very simple, make it very simple. The JAINs are nothing, the packets which are oversized. Okay, that means the size of the packet will be big here. So this packets, okay, the interface, fast Ethernet 0 by 0 or 1 by 0, anything, they cannot forward these packets. Okay, they cannot forward this packet. So these packets will be completely dropped. So this is called JAIN packets. Okay, you see. So JAIN packets will be discarded. It will be discarded. Okay, why? Why it will be discarded means because exceed the maximum packet size, okay, for the medium. So it will exceed the size, the maximum size. What is the maximum size we can have? Okay, for a switch. Okay, that means a Ethernet packet, we can say frame. So what is the maximum size means? The maximum size it should be 1518 bytes, 1518 bytes. So any Ethernet packet, we can say Ethernet packet or we can say a frame. So any frame or Ethernet packet, if the size is greater than 1518 bytes, so that particular Ethernet packet is considered as a JAIN packet. So the JAIN packets will be dropped. Okay, that means your switch is not going to forward the JAIN packet, that means the big packets. So automatically the packet will be dropped. So in this case, in fast Ethernet 0 by 1, there is no JAIN packet, 0 JAIN packets. We have not received any JAIN packets. So JAIN means the oversized packet, okay, in single word, it is oversized packet or the size will be more, okay, it will be greater than 1518 bytes. 1518 bytes. This is JAIN packets. Now, what is runs? Okay, runs packet means the packet which is less than the minimum size. So we need to maintain a minimum size. What is the minimum means? 64 bytes is the minimum. Okay, 64 bytes is a minimum size for a Ethernet frame. If it is less than 64 bytes, okay, if it is less than 64 bytes, it is considered as a runs. A run packet also, your switch, okay, that means the interfaces in the switch, it will not forward, it will drop. Okay, it will drop the run packets also. You can see the packets that are discarded, because they are smaller than the minimum packet size for the medium. For example, if it is less than 64 bytes, it is considered as a run. Okay, it is considered as a run. So run packet means the packet which are minimum in size. Minimum means that means less than minimum 64 bytes, less than 64 bytes. So we cannot consider this as a frame or a packet, Ethernet packet. It will be dropped. So in the previous case, you can see 0 runs. We don't have any runs in this interface. We have not received any runs in this particular case. Okay, 0 runs. There. The next one, it is CRC, cyclic redundancy check. So what is CRC? Cyclic redundancy check means the frames which is having the errors. So in the last class, we discussed there are two different types of switches. The switches will work in two different ways. So what are they? The first one, it is a store and forward method, and second, it is called the cut through method. Okay, two different methods. So in the store and forward method, the entire frame, okay, it will receive. Then it is going to check the errors, CRC. After that, it will forward. Okay, so CRC means which is used to check the errors. Okay, now you can see CRC errors are generated when calculated checksum is not the same as the checksum received. So if anything, okay, you are receiving a frame. Okay, a frame is coming to your, okay, to the switch. Now the frame, okay, the switch is going to calculate the CRC for that. Already there is a CRC available inside the frame. If this two CRC is not matching, means this frame is a error. This frame is having an error. So now CRC frames, if there is any error, CRC error available, means automatically your switch will discard. It will drop that particular frames. Now you see the previous slide. In the previous slide, there are three different frames, okay, which is having the CRC problem. So three, okay, frames having the CRC, that means some problem error available, automatically these particular frames will be dropped. It will not be forwarded. Then the next one is the input errors. Input errors and output errors. Okay, you can see the input errors and the output errors. So what is that input error means? Input error means total number of errors. Total number of errors. Okay, if it includes runs, JAINs, no buffer, CRC, frame, overrun, and ignored. So all these things total. Okay, go to the previous slide. You can see the input error. How many input error means you have to add everything 0. 0 runs, 0 JAINs, 3 CRC, 0 frame, 0 overrun, 0 ignored. So all these things if you add, that is going to be the input errors. So totally there are 3 input errors available in this case. So 3 frames dropped. Okay, in fast Ethernet 0 by 1. In fast Ethernet 0 by 1. So due to some reasons, okay, due to the runs or JAINs or CRC problem, so 3 different, okay, 3 packets dropped. Then the next one is output errors. So what is output errors means? You can see the output error, sum of all the errors that prevented the final transmission of the datagram out of the interface that is being examined. Sum means total. Total of all errors that prevented the final transmission. Okay, that stopped the final transmission of the datagram out of the interface. So from the interface, okay, that means the final transmission is going to be prevented. It is going to be stopped. So that is called the output error. Okay, so input error means the frames which are coming in. Output means the frames which are going out. Okay, the frames which are going out. So in that, okay, how many number of errors available? Now the next one is collisions. So collision and late collision. So what is collision? We already know. We studied about this collision in the last lecture. So that means a single link. A single link will be used by more than one. Okay, more than one at a time. So there will be a collision. So if collision happens, automatically you have to retransmit that packet. Okay, you have to retransmit the packet. Now you can see the number of messages retransmitted because of collision, because of Ethernet collision. So in the previous slide, okay, if there is any collision means, okay, they are not mentioning anything about the collision. Yeah, collisions. Okay, you can see 1790 collisions available. Okay, 190 collisions available. Okay, then the next one is, you can see the next one, late collision. So what is a late collision means? It is also a collision, jammed signals that could not reach to the end. Okay, you cannot do retransmission. So sometimes you will have jamming collision, but you cannot do any retransmission. That is called the late collision. So late collision, okay, you can see 253 late collision available in this interface. So what exactly we are studying here means, this is called the statistics. Okay, a statistics. Yeah, okay, if you are taking fast Ethernet 0 by 0, for fast Ethernet 0 by 0, how many runs available, how many JAINs available, how many CRC errors coming, how many input errors, output errors, collisions, late collisions. So you can check everything for a single interface. Okay, you can do like this. So this is about different parameters, that means the different types of errors which may happen for a packet. Now, the next one is troubleshooting a switch media connection issues. So what is that means? You see, I'm taking a switch. Okay, so this is a switch. There are 24 ports available. So this is port number 0 by 0, 0 by 1, 0 by 2. Okay, there are 24 ports available in this switch. Okay, so I'm going to take a PC. So this is a PC. I'm going to connect the PC in the switch. So there are different devices. So if it is different devices, you can use a straight through cable. So using the straight through cable, okay, you can connect. Okay, you can connect a switch. Now suddenly this, okay, system is not getting any data. It is not receiving any data. So there may be some problem, some error available in this interface. A fast Ethernet 0 by 0. There will be some problem available here. So I want to troubleshoot. I want to find the error. Okay, I want to find what is the error. Now I'm just going to the switch. I'm going to enter into this switch and I'm going to type the command show interface fast Ethernet 0 by 0. Okay, show interface fast Ethernet 0 by 0. Okay, you can type this particular command. So to check this is troubleshooting. Okay, so now I'm going to use show interface fast Ethernet 0 by 0. Now if I use the command, it will say whether it is up or not. You see, fast Ethernet 0 by 1 is up. Fast Ethernet 1 by 1, okay, 0 by 1 is up. If it is giving up means that is on. Fast Ethernet 0 by 1 is working. So you have to check whether it is on, whether it is up or not. Okay, you have to check whether the fast Ethernet 0 by 1 is up or not. If it is up, yes. Or if it is no, if it is not up. Okay, we will go for no. If it is not up, check the cable. Verify the proper cable. Maybe problem in the cable. Then check the cables and the connectors for the damage. If there is any damage available in the connector. Connector means like the RJ45 connector. So in the RJ45 connector, if there is any damage, check it. Then verify the speed. We already fixed this. Okay, the speed, duplex, okay, auto, all these things we have to check. Okay, now if it is working, if the problem solved, means yes, everything is done. Suppose if, okay, I have done everything, I checked everything, teacher, but no, still I have the problem. Okay, is the problem solved? No, I could not solve the problem. So in that case, what you can do means you can write it. You can document this and you can send it to your next level. You can send it to your administrator. Now you can come to the next branch. Okay, what does that means? I give the command show interface fast Ethernet 0 by 1 or 0 by 0 anything. Is the interface up? Yes, it is up, but still it is not working. Then you check for any indications of EMI or noise. So check for the EMI means noise means maybe some electrical things will be available near to the device. Maybe some magnets will be available. Okay, that is called the noise. Okay, if there is any devices like that, you can remove that device. Then verify the duplex settings. Duplex settings is properly done or not. Okay, in both the sites. You have to check whether the duplex, okay, auto MDI, everything is properly okay done or not. So if it is done, okay, then if the problem is solved, yes, done. If the problem is not, still you are having a problem means you can write it, you can document, and you can send it to your administrator. So we are having this particular problem. So this is a very simple method, okay, how you can troubleshoot a particular interface. Okay, I'm taking fast Ethernet 0 by 0. So the fast Ethernet 0 by 0 is having some issues means you can fix the errors like this. Then the next one, okay, so this is the end of this particular part. Okay, just we can recap what we studied. So we studied how you can fix the errors. Okay, first thing, finding the errors. So these are all the different types of errors: runs, JAINs, input errors, CRC, output error, okay, collision, late collision. Okay, these are all different types of errors. It may happen. That means different types of errors for every interface. Okay, for every interface. Now next one, you can do the troubleshooting. So this is the algorithm, okay, or you can flowchart, okay, not algorithm. So this is the flowchart. So using this particular flowchart, you can find the, you can detect the errors. You can troubleshoot a particular interface. Then, so I'm going for the next part. So what is the next part of this lecture means? SSH configuration. Okay, SSH configuration. So SSH is secure shell configuration. Okay, now you can see this is a switch. I can enter into the switch by using, okay, some remote management or remote login. By using any remote login method, you can enter into this switch. Okay, you can enter. For example, the very popular tool is Telnet. So you can use Telnet, and using the Telnet, you can enter into the switch. So if you want to enter into the switch, you need the IP address for the switch. Okay, we already know in the first part of this lecture, we already fixed the IP address. How to fix a IP address we discussed. How to fix a gateway we already discussed. So using that IP address, okay, for example, Telnet 10.0.0.1. Okay, I make a very simple IP address, but in your slides it is given 172.17.99.11. Okay, so by using this IP address, I'm going to enter into this switch. Okay, we have done this in the router. We have done this in router. We fix the password also for this. Okay, now if I use Telnet, Telnet is not a secured protocol. Okay, Telnet is not a secured protocol. Telnet is a how to say, it is a plain text protocol. So plain text protocol means, okay, it will not encrypt anything. Nothing will be encrypted in Telnet. So easily the attackers can capture. Okay, easily the attackers can capture your packet and they can take any username, password, whatever it is available. So using Telnet is not advisable. Okay, using Telnet is not advisable. So what we have to do? So we have to go for the next protocol, which is called the SSH protocol. Secure shell protocol. So you can use a secure shell protocol and you can enter into the switch. So why I want to go for SSH? Because SSH protocol provides a secure, a encrypted, it is going to encrypt everything. So any communication or any transaction or any transmission between the sender and the switch, everything will be properly encrypted. Now we are going to discuss how to configure SSH. Okay, we are going to see. Okay, we are not going to do it practically, but we are going to see the commands only. Now, so SSH, it is commonly used Unix based system, and here, okay, your Cisco devices, any devices, if you take either it is a router or a switch, so it will support SSH. It is supporting the SSH protocol. Then a version of iOS software including the cryptographic encrypted features, okay, it's nothing. It is going to any switch 2960, it is a switch. So any switch if you take, automatically they are supporting SSH, okay, because SSH is a strong encryption feature. It is having a very strong encryption features. Then SSH should be replaced the telnet. So we are not at all using the telnet. So because telnet is not a secured protocol. Telnet is a plain text protocol. Okay, so we are going to completely remove the telnet. So instead of telnet, we can use the SSH protocol. Then, if you take the port numbers, so what are the port numbers means? If you use SSH is going to, okay, use the port number 22. So what is the port number assigned for telnet? For telnet, okay, for telnet, port number 23 is assigned. So already we know this. Port number 23 means telnet. Port number 22, SSH. Port number 80, it is HTTP, Hypertext Transfer Protocol. So 22, it is SSH. 23, it is telnet. Now, we can see how to configure, okay, how to configure a SSH protocol. Okay, now you can see here. So this is a switch. I want to configure the SSH protocol here for remote login. Okay, for remote login, I want to configure the SSH protocol here. So what I'm going to do, I'll go to the switch. I'll go to the global configuration mode. In the global configuration mode, the first command, what is the first command? Only there are 5 lines. So what is the first command means? I want to create a domain name. Okay, you can create a domain. So what does that means? How to create a domain? IP, domain name. So this is the command. You cannot do any changes in that. Then you can give any name as a domain. So if you take our college, so we used to give cas.edu.om. So that is our domain. Okay, cas.edu.om. So this is the name of the domain I'm going to create. You can give any name, sur.com, hello.com. So you can create any domain name. So IP, domain name, you can give any name. Okay, so the domain name is created. Then the next step is you have to create, you have to generate the keys, because here everything is going to be encrypted. So what is the encryption algorithm? Okay, the default encryption algorithm used in the SSH, okay, is RSA algorithm. So RSA is the default algorithm used here in the SSH protocol. Now I'm going to generate the keys. So how to generate the keys? Because RSA algorithm, it is a asymmetric algorithm. You need public key and private key. Okay, you need a public key and private key. So automatically it will create. You don't need to do anything. Automatically it will create the keys. RSA keys it will create. Now you can see the command is crypto key generation. Generate. This is the command. Crypto key generate space. Okay, the name of the algorithm. Name of the algorithm is RSA. So if you give, automatically it will ask, okay, it will request you, okay, how many bits of modules, okay, it will ask for the size of the key. So what is the size of the key you need? So you can give 512, 2024, 2048. So you can fix the size of the key. So in this case, we are giving 1024 as the key size. So if you give, it will take some time to generate the keys, but you cannot see the keys. So automatically the keys are generated now. So first I created a domain name, IP, domain name. So the name of the domain I gave. Then crypto key generate RSA. Then it will ask you to enter the size of the key. So you can give the size of the key. So the key will be created. Finished. Then the next one is you are going to create a username and a password. So this is the username and password we have to use. So if you want to enter into the switch, okay, you are going for the SSH, then you can enter here by using the IP address. It will ask the username and password. Everything will be encrypted between you and this switch. Now you see the command. So what is the command means? Username. You can select any username. Okay, I'm giving the username as admin here. Then the next command is a password, and you can give anything as a password. So I'm giving admin CCNA as a password. So the username is admin, password is CCNA. So the next one is VTY, line VTY. We have done this command in the routers. So line VTY 024025667. You can give any number. Now the next command is transport input SSH. So all the transport, it is going to be using the SSH protocol. Then login local. So if you configure this in a switch, then from any device you can enter into this switch by using the IP address, but you have to, everything will be encrypted. Whatever the packets you are sending from here to the switch, from switch to this device, everything will be properly encrypted. So even the attacker is capturing this packet means they cannot read anything. Okay, it will be completely encrypted. Now, so there is a YouTube link available here. So this is okay, my channel. So I have done a small topology. Okay, so to configure the SSH. Okay, you can just have a look. If you go to this video, you can see how the things are working. So what we study here means, then the next one is verifying the SSH. So this is a command, a very simple command, show IP SSH. So if you give this command, it will display the information about the SSH protocol. Okay, you see. So SSH is enabled. What is the version we are using? 2.0. Then authentication timeout. Timeout means 90 seconds. So 90 seconds, if you are not giving any response, automatically it will be logged. It will be, okay, the session will be closed. You will be logged out. Then how many times you can try? That means the wrong passwords. 2 tries. Then you can see these are all the keys. Okay, so these are all the keys. So keys, you cannot understand anything from this key. These are the keys available. So you can see the what to say. You can see the information about the SSH protocol like this. Okay, the next one. Okay, so this is the end of this particular part. So just I'll show you SSH configuration. Telnet protocol. It is not a safe protocol. It is a plain text protocol. You can use the SSH protocol. So how to configure the SSH protocol? Okay, these are the commands. So you have to configure these commands in your switch. Then you can see the verify. You can verify your SSH by using show IP SSH. Okay, so this is about configuring the SSH protocol. So you can go through the video. Okay, I have done a small lab. Okay, it's almost 20 minutes only. Okay, a very small lab. Now, the next part of this lecture is security concerns. Security concerns in local area network security problems. Okay, now here we are going to discuss 1, 2, 3, 4. 4 different types of security issues we are going to discuss. Okay, so the first security issue is MAC address flooding. If you take a switch, MAC address flooding is a very big issue. Second one, DHCP spoofing. This is the second problem. The third problem is leveraging the Cisco discovery protocol, and the fourth problem is leveraging the telnet protocol. So now let me go in the reverse. Okay, because just now we studied about this telnet. Okay, just now we studied about the telnet. So let me start from here. So if you use telnet, okay, telnet is insecure. We already know this. It is a insecure protocol. Now, telnet protocol, it is completely replaced by the SSH protocol. So nowadays we are not using the telnet. So we are using the SSH protocol. Okay. Suppose if you use telnet, what will be the problem? Okay, if I use telnet, I'm not using SSH. So what could be the problem means you can expect 2 different types of problems from the attackers. So the first problem is brute force password attack. So the attackers can easily capture your passwords. This is first problem. The second problem is they can create a denial of service attack. Telnet denial of service attack problem will be available. So these are the two different issues. Okay, if you use Telnet, I'll go for the first one. So what is the first one means? Passwords. Now, attackers can easily capture your passwords. I already told. Suppose if the passwords cannot be captured, if the password cannot be captured means the attackers will try as many combinations. This is called brute force. So the attackers will try different combinations of characters as possible, and they will guess your password. So this is called the brute force. I know some basic information about you. I know, okay, your mobile number, your name, okay, your car number, your student ID. So I know basic information about you. So using this basic information, I can try your password. I can guess your password. So what could be your password? Easily I can guess. So this is called brute forcing. So telnet can be used. Okay, so first I'm going to use telnet 10.0.0.1. Okay, I enter into your switch. It is asking enter the password. I'm going to try first password. Okay, it is not working. Then again, I'm going to try the second time, another password. Not working. Third password, not working. No issues. Again, okay, the connection will be closed. Again, I'm going to use telnet. Telnet 10.0.0.1. So you can brute force the password very easily by using the telnet. So there is no limitations. You can try any number of times. Then you can create a denial of service attack also. So what is denial of service attack? I'm just going to run, okay, telnet 10.0.0.1, okay, connector. Again, I'm giving telnet 10.0. So what does that mean? I'm keep on giving telnet to you. I'm going to make your machine busy. I'm keeping your server, okay, not server here. It is going to be the device switch. So I'm going to keep your switch, okay, completely busy. So this is going to be creating the denial of service attack. So attackers can easily run the denial of service attack by using the telnet protocol. Okay, so telnet server software running on the switch, and it will become completely, this will be available, unavailable to others. So I take command prompt 1, command prompt 2, command prompt 3, command prompt 4. Okay, in my machine, I'm taking the command prompt. I just connect with your machine. So five command prompts, okay, it is connected with your switch means, so 5 connections already connected. If a 6th person is coming means he cannot connect. So this is denial of service attack. Okay, so denial of service attack is very easy. A attack that prevents the administrator for remotely accessing the switch management. That means you can stop the administrator, okay, to enter into the switch. We can make the device busy. Okay, we can make the device busy. So this is called, okay, telnet. Using the telnet, you can create a denial of service attack to any switch. Now, the next one is leveraging the Cisco Discovery Protocol, CDP. Okay, CDP is a protocol. So this protocol, if you enable this protocol, okay, for example, if you see, I'm sitting in the college machine, I want to know how many Cisco devices available in our college, in the college network. So what I'm going to do, I'm just going to enable the CDP, Cisco Discovery Protocol. Okay, I'm going to enable. Now the Cisco Discovery Protocol is going to run in the entire network, the complete college network, and it is going to search where the Cisco devices available. It will find all the devices and it will bring it, okay, the list. It will give me the complete list. Okay, it will give me the complete list. So the complete list shows, okay, how many devices available, what is the name of the device, everything I can find it. Okay, now just think, I am an attacker. I want to know how many devices, Cisco devices available in our college network. So I can sit in any machine in my network, in our college network, and easily I can find. Okay, see, Cisco Discovery Protocol, CDP. So CDP is a layer 2 protocol. Okay, it will work in layer 2. That means it will work in a local area network, only within the local area network. Then this protocol, Cisco Discovery Protocol, used to discover, okay, Cisco proprietary protocol. Okay, proprietary means this is created by Cisco. Okay, it is created by Cisco, and this is used to discover the other directly connected Cisco devices. All the directly connected Cisco devices easily you can discover within a network. Okay, within a network. Not only that, the CDP is designed to allow the devices to auto configure their connections, and if a attacker is listening, if a attacker is using the CDP, this is going to be the dangerous part. If the attacker is listening to the CDP, Cisco Discovery Protocol messages, it could, okay, the attacker can learn important information about the device model. So what is the device model you are using? What is the running software version? What is the operating system running in that? So many information the attacker can get it. How many devices available? Where the devices are installed? So the plenty of information, okay, the attackers can get it. So this is the second problem, okay, in the networks. That means in the local area networks, okay, because of CDP, Cisco Discovery Protocol. Now you can see note. What is a note means? Cisco recommends, okay, Cisco itself they are recommending to disable the CDP. So you have to disable the CDP, Cisco Discovery Protocol, when not in use. When you are not using, okay, please kindly disable the CDP protocol. Now, the third problem is DHCP snooping problem. Okay, so what is a DHCP snooping means? An attacker enter into your network, he can play with the DHCP. So you know what is a DHCP? Dynamic Host Configuration Protocol. So using this DHCP, you can assign the IP address. Okay, the DHCP server or the DHCP machine can assign the IP address to all the network. That means all the to all the host. Okay, in a network. So that is the DHCP. So using DHCP, you can create two different types of attacks. That means the attackers. So one is the DHCP snooping, and second one is a DHCP starvation. Okay. So what is DHCP snooping attack means? Snooping means a fake DHCP server. So in your network, generally there will be one DHCP server, but the attacker, what the attacker is going to do? The attacker is going to create another DHCP server in the network. A fake DHCP server is placed in the network to issue the DHCP address to the clients. So this is a very serious problem. Okay, attacker is going to install. Okay, it's very easy actually. Installing, okay, creating a DHCP is not a very toughest job. So you can take any machine in our lab and you can install the DHCP software and you can become a DHCP server. Okay, so easily we can, okay, we can assign the DHCP, okay, we can create a fake DHCP machines, okay, in a network. Then the next one is DHCP starvation. So what is DHCP starvation means? Starvation is artificially, you can see the word artificially, you can create a starvation for the IP address. So what is that, teacher? You can see in the next slide. What is a starvation means? Okay, wait, where is the starvation? Oh, it's only snooping there. Okay, so what is starvation means? Starvation means like things not enough. Okay, water starvation, food starvation. Okay, so that is called the starvation concept. So now a DHCP, suppose a DHCP is giving 100 IP address. Okay, a DHCP is providing a capable, okay, a DHCP server, it is configured to provide 100 IP address. Okay, for example, I'm giving. Now the attacker, what the attacker will do means, the attacker will take all the IP address, the attacker will take all the 100 IP address, he will take it from the DHCP server. Now, if a new machine, okay, the another machine, okay, if it wants an IP address, automatically a starvation is created. So the DHCP will tell, okay, we don't have enough IP address. So a DHCP server, okay, So artificially we are creating, artificially we are creating a starvation. The attacker will create a starvation in the DHCP machines, in a network. So this is about the DHCP starvation. Now, DHCP snooping, you can see. So what is a DHCP snooping means? A fake, a fake DHCP, a server. You see, this is a network. In this network, this is our legitimate DHCP server. This is the actual legitimate DHCP server. Now, this person is a attacker. Now, the attacker is going to claim, the attacker is going to broadcast, I am the DHCP server. If anybody wants the DHCP, please come to me. Or suppose this machine is asking, I need a IP address. So this machine is going to broadcast. Now if any broadcast comes, automatically this person is going to provide the IP address. So this is called a rogue, a rogue DHCP attacker. So an attacker is going to become a DHCP server in our network. So this is called DHCP snooping attack. So these are all different types of attacks possible. Then the next one, the very important thing is MAC address flooding. So this is a very important attack. A very important attack as far as switches are concerned. Now I'll directly go to the example so that you can understand very easily. So the remaining theory part, you can just go through that. Now, if you take a switch, this is a switch. Every switch is going to maintain a table. Every switch is going to maintain a table. The name of the table is called MAC address table. So we can say MAC address table, or we can say CAM table, CAM table. Anything you can say. Now, so I'm going for, this is, let it be switch 1. So for this switch, a MAC address table should be created. A MAC address table should be created like this. So what is that means? Port. Port and then MAC address. This is the actual MAC address table for S1. What is that means? In port number 1. So in the port number 1, port number 2, port number 3. There are 3 ports available. In port number 1, who is connected means MAC address A is connected. So port number 1, A is connected. Then in port number 2, so who is connected means in port number 2, B is connected. In port number 3, who is connected means port number 3, C is connected. This is the correct MAC address table. The MAC address table should be like this. We can say MAC address table, or we can say it is a CAM table. So the table should be like this. But the attacker is going to play. The attacker is going to enter some fake information. The attacker is going to enter into this MAC address table. This is called MAC address flooding attack. So in this CAM table, the CAM table should be like this, but the attacker is going to flood. The attacker is going to flood some bogus. Bogus means some fake addresses the attacker is going to fill in this table. How? You can see. So this is switch 1, MAC address A, MAC address B, MAC address C. Now this person is the attacker. He is the attacker. Now the attacker is creating the frame. The attacker is creating a frame. He is creating a frame. So in the frame, we have to give the source MAC address. Source MAC address. Every machine should provide. A source MAC address. They have to provide. Now, so this person is creating. The attacker is creating a frame. In that, in the source MAC address, my original MAC address is C. The original MAC address is C, but he is not going to give C here. He is going to give a fake MAC address. A fake MAC address is giving. Now he is giving X is my MAC address. Source MAC address is giving, and he is going to broadcast that packet. He is going to send it to the switch. Now, so the frame is going to the switch is receiving. Now the switch is going to see, it is going to open the frame. So in the frame it is written X. So X is available in port number 3. Now your switch is going to write X is available in port number 3. So actually X is a fake MAC address, but the switch is going to enter, it is going to enter into the MAC address table, or in the CAMP table it is going to enter X, it is connected in port number 3. Then the next frame again, okay, the attacker is going to create one more frame, okay, one more frame the attacker is going to create, okay, one more frame the attacker is creating. So now the attacker is going to give, okay, my source MAC address. So my source MAC address is, okay, my source MAC address is, now he is giving Y as a source MAC address. Now he is sending the frame to the switch. So the switch is learning what, okay. So now the switch is opening the frame. So it is written Y. So Y is connected. Now your switch is going to update your switching table or CAMP table or MAC address table. So Y is connected in 3. Y is connected in 3. Then again, okay, the attacker is creating another packet. Now in the packet, the attacker is going to give his original MAC address. So my source MAC address is, okay, my source MAC address is, okay, the attacker is giving, now is giving the real MAC address. My MAC address is C. Now again this packet is going to the switch is learning, okay. So that means C is connected in 3. C is connected in 3. Okay, C is connected in 3. So now you see your MAC address table, the switch MAC address table is consists of this data. This is going to be a fake data, but this is going to be the correct. Your switch should be like this, but a attacker by changing his MAC address is going to create a fake, okay, see, bogus address are added to the MAC address table. Attacker starts sending unknown bogus MAC address. So bogus means fake, false. Then X and Y, okay, we know X and Y are on port number 3 and the MAC address table is updated. Okay, MAC address table is updated. So now we have completely have a fake data in the MAC address. That means your switch has been cheated now. Okay, the attacker cheated the switch. So the switch is thinking, okay, X is connected in 3, Y is connected in 3 and C is connected in 3. Now the first machine, okay, you go to the first machine, the first machine is going to send a frame. Okay, the first machine is sending a frame. Okay, so the first machine wants to communicate with B. I want to communicate with B. A wants to communicate with B. So now, so A is creating a packet. I want to send the packet to B. So from A to B, I want to send a packet. Now what is happening? So the packet is come to the switch. Okay, it's coming to the switch. So in the switch, they are going to check in the switching table. So they are going to check in the MAC address table. So where B is connected. Where B is connected. So the information is not available here. X is connected, Y is connected, C is connected. But where B is connected, so we don't have, because our table becomes full. The MAC address table, it is become full. Okay, why teacher, why it is full? Why we cannot add 4th line, 5th line? You cannot add, okay, because only 3 things connected here. 1, 2, 3. Only 3 entries. So your MAC address table become full. Now, so your switch is going to search, where is B? Where is B connected? So it is checking X, Y, C. Okay, there is no information about B. Okay, there is no information about B. So what your switch is going to do? Your switch is going to broadcast the packet to all. It is going to broadcast the packet to all. Okay, so the packet, it is going to broadcast. So a packet is going to be at the same time, a packet is coming to C. C is our attacker. The attacker is waiting for this. So whatever the packets from A to B, the attacker is going to take a copy. Okay, whatever the packets going from A to B, the attacker is taking a copy of the packet. So now the attacker is doing, okay, is capturing the somebody's packet. Same thing. If B is sending a packet to A, okay, from B to A, if a packet is moving from B to A, the same thing is going to happen. So if a packet is going from B to A, it will go to the switch. So the switch is going to search where is, okay, A connected. There is no information because it is already full. Now the port, that means the switch is going to broadcast. So if the switch is broadcasting, the packet will go to A and a copy of packet will come to C. So now the attacker is just, okay, is making your MAC table full and is going to capture all the packets. He is capturing all the packets. Okay, if you are studying network security A, in sniffing lecture, you studied the same concept you studied. So this is how we can use the MAC address table, how the attackers make use of the MAC address table and they can have attack. Now this is a switch, but the switch is now acting like a hub. Okay, this is a switch, but the switch is going to act like a hub. So hub means like broadcasting, broadcast. So this is how, okay, a MAC address concepts will be used for attacking. So 4 different concepts we studied here, the security concerns. So we discussed about the first one is a MAC address flooding. Second one is DHCP snooping and DHCP starvation also we studied. Then leveraging the Cisco discovery protocol. Then leveraging telnet. So using the telnet protocol. So these are the 4 different types of attacks we studied here. Then the last topic here, switch port security. So how you can avoid all these types of attacks? How we can avoid means you can have a concept called switch port. That means port security. Okay, each and every port, fast Ethernet 0 by 0, fast Ethernet 0 by 1, 0 by 2, 0 by 3. So each and every port, okay, you can have some security. Okay, you can have security in each and every port. But in our lectures, okay, the port security is not properly covered. Okay, it's not properly covered. They are just giving some introduction. Okay, it's not given in depth. Okay, but anyway, we will see. So the first concept here, secure the unused ports, DHCP snooping, network time protocol. Okay, only 3 things. Okay, even network time protocol is not port security. So only 3 things we are going to discuss. Okay, now I'm going for the first concept, which is secure the unused ports. What is that? You see, this is a switch. Okay, this is a switch. So in this switch, you take 24 ports available. 24 ports available, but I'm connecting only one port. Only one I'm connecting. The remaining 23 ports are going to be free. So this remaining 23 ports, you have to close it. You have to keep it closed. You have to shut down. If you have not shut down, attackers can easily enter into that. Okay, you see, I'm going show running configuration. Okay, I'm giving. Now you see, okay, fast Ethernet 0 by 0, it is shut down. Good. Fast Ethernet 0 by 5, shut down. Fast Ethernet 0 by 6, it is not shut down. There are something going on there. So description, web server, there is something happening here. Fast Ethernet 0 by 7, it is shut down. So this 0 by 6 is going to be vulnerable now. In 0 by 1, I connected the PC. In fast Ethernet 0 by 1, I connected this PC. It's good. So this will be on. But if you see 0 by 6, okay, for some reason the port, okay, the port is kept open, but there is no connection, no physical connection here. So that means 0 by 6 is going to be in the trouble. It is going to be vulnerable. So what we have to do? Disable the unused ports. If any port is unused, you have to disable it by using the command shutdown command. So by using the shutdown command, so keep the unused ports shut down. This is the first concept. So very simple technique. Okay, a very simple technique. So disabling the unused ports is a simple yet efficient security guideline. So it's a very simple concept, but it is very efficient. Now, the second concept is DHCP snooping. Okay, so what is the DHCP snooping means? DHCP snooping specifies which switch port can respond to the DHCP request. Okay, so what does that mean? We already discussed. This is our original DHCP server. Okay, this is our original DHCP server. And this is our fake, okay, a fake DHCP server. Okay, a fake DHCP server. So what you can do means you can configure the ports, which port is, okay, which port is going to respond for the DHCP request. Okay, which port is going to, okay, respond, which port is going to be like, okay, which port is going to respond for a DHCP, which port should not respond. Okay, we can make. So this is port level we are going. Okay, you see this fast Ethernet 0 by 1, it is connected with the DHCP server. So I'm going to make this fast Ethernet 0 by 1. I'm going to allow, okay, to respond to the DHCP request. If any DHCP request comes here in fast Ethernet 0 by 1, I'm going to allow, okay, to give the response. Same 0 by 2, this also I'm going to make it. So that means we are going to make this as a trusted ports. Then fast Ethernet 0 by 1, I'm going to make this as a trusted port. But this machine, I don't want this machine to give any DHCP reply. Okay, they can give request, but they should not give any reply. So fast Ethernet 0 by 3, I'm going to make it as a untrusted. Same thing, PC1, I can get DHCP request, but this machine should not give any DHCP reply. So what I'm going to do, I'm going to make this fast Ethernet 0 by 2, I'm going to make it as untrusted. So you can make a port as a trusted port and you can make a port as an untrusted port. So if it make it as a trusted means they can give the reply to the DHCP request. Okay, so DHCP snooping allows the configuration of the ports as trusted or untrusted. If it is a trusted port, so trusted ports can send the DHCP request and acknowledgements. Untrusted ports can forward only the DHCP request. So they can forward, untrusted means they can forward only the DHCP request. They cannot forward any, okay, acknowledgements and all they cannot do. Even reply they cannot give. They should not give any reply. So you can avoid the DHCP snooping problem. Okay, by using this particular concept. So you can go to the port, you can configure the port as a trusted port or you can configure as an untrusted port and you can avoid the DHCP snooping concept. So what does that means? You have to work in the port level. Okay, you have to work in the port level. We are going to do in the next lab. We are going for lecture number 9. Okay, there is going to be the VLAN. So how to create a VLAN and all we are going to discuss. Now, the next one is time protocol, network time protocol. Actually, these two are DHCP snooping and unsecured, secure the unused ports. These are the two things, port level security. Okay, port level security. And the last concept is NTP, network time protocol. So what is a network time protocol means? So this is a protocol which is used to update the time in a network. Okay, even if you see in our college network, all the machines, all the client machines will have the same time. Okay, even seconds. Okay, it will be same in all the machines. How it is possible means we are having a protocol. The name of the protocol is NTP, network time protocol. So the network time protocol will be running in a device. Okay, you can have it in a PC or you can have it in a router. Okay, anywhere you can have this NTP network type protocol, and this NTP protocol, it will be keep on updating your devices, the network devices. See, NTP network time protocol is used to synchronize the clocks of the computer systems data networks. So in a data network, it used to synchronize the time. Okay, every seconds. Okay, it will update. It will keep on updating the time. Now, NTP can get the correct time from the external or internal or external time source. So the NTP can get the time from anywhere. Network time protocol, it can get the time from external, from the internet, you can take the time, or from the, sorry, external. External means from the internet they can take, or internally you can configure the time, you can do anything. So if you're going for a, okay, that means the time sources, local time master, that means local master clock you can have, or from internet, master clock on the internet, or from the GPS. So anywhere you can fix this, so automatically it will update the time. So you will be having a NTP server and you will be having the NTP clients. So there will be, okay, lot of clients. Everybody in your network, all the machines in your network will become a NTP client. Now, so you can see in this example, I have two routers I'm connecting. So these two routers, one router I'm going to make it as a server, and another router I'm going to maintain. Okay, I'm going to make it as a client. So this router R1, it is keep on updating. Okay, keep on updating the time. So this is going to be the, okay, master, and this is going to be the client. Now, so this is not, they are not even covering, okay, completely, just they are given. Now you can see the command NTP associations. So if you give the NTP association means how many people are connected, okay, the IP address, what is IP address of that, everything, the complete information you can get. So it's not completely given. So just they just introducing what is NTP. That's it. Okay. So in this part, that means in the switch port security, securing unused ports, this is very important, and DHCP snooping is very important. How you can avoid, okay, the DHCP attacks by using port security. Okay. So what we studied in this lecture means, so we covered 6 different parts: switch introduction, basic switch configuration, layer 2 and layer 3 issues, SSH configuration, security concerns in the local area networks, and finally switch port security. Okay, so these are the things we covered here.